that explains why you couldn't record the class because Leo did not see the ring. Okay, so quickly. Yes, somebody was asking for which question? 2A. 2A. Did I copy it? That's what I have here? Maybe just say, okay. 2A. Solve the equation. All right. It's 10, right?
Yes.
Yes.
10 days to Christmas.
I think this is okay.
10?
Okay.
Wait, break us next week.
Yeah.
Oh no.
So 2A says, solve the equation. Z cube equals 2 plus 2I. Yes?
Yep.
And display the solutions on an Eigen diagram. Okay. So basically, if Z is that, if Z cube is this, then Z is the cube root, yes, of 2 plus 2I. So basically, this question is to find the cube root of 2 plus 2I. The cube roots. Because there are how many of them?
3.
According to
Law of algebra.
the fundamental
0.
theorem of algebra. Yes. According to fundamental theorem of algebra, every polynomial of degree n has n roots. And this is a polynomial of degree 3, so there should be 3 roots. So, the first thing, yesterday I said this is more or less cube root of w. So my focus is now on w. I find the modulus of w, I find the argument of w. Now for the modulus of w, I get the square root of 2 squared plus 2 squared. So w is this, right? And that gives the square root of 8, yes? Which is 2 root 2. Okay? For the argument of w, you do, so try to plot w in an Eigen diagram. If you plot w in an Eigen diagram, 2I, so you have something like that, yes? So my alpha and theta are the same, basically, here. My alpha is this, my theta is that also. So I can go straight to get it, and it's positive. So tan theta, or let's say tan alpha, maybe I go with that. Tan alpha is 2 divided by 2, which is 1. So this implies that my alpha is arctan of 1, which is 45 degrees, yes? So which means the argument of w, which is the theta, is 45 according to the Eigen diagram. There's no need to subtract. No, not 45. I keep thinking in degrees. So that's pi over what? 4. So you just pi over. Okay? So having said that, so what is the root of complex number w? From yesterday, we said the nth roots of any complex number is what? What? I change r to something else. Absolute value to power n, because this is going to be a number, not a complex anymore. It's going to be real, so this can be evaluated on its own. Followed by what? CIS, yes. The argument plus 2k pi divided by n. And k is from 0 up to minus 1. So now we are asking for cube roots. So there are 3 of them. So our k will we count, the loop will be from 0, 1, and 2. Yes? So let's substitute. So basically in this case I'm just going to substitute. So the cube root of w will be the absolute value of w, which is 2 roots 2 to power 1/3. Yes? CIS theta is pi over 4. I'm going to say this, pi over 4 plus 2k pi. This is main being OCD. Yes? Not 3, not n this time. 3. Yes? Then our k will be 0, 1, 2. So let's simplify that. Do you agree this is 2 to the power 1 times 2 to the power half? And that's 2 to the power 3 over 2. Am I too fast?
Sorry, say that again?
2 root 2 is 2 to the power 1, 2 to the power half, 2 to the power 3 over 2. Yes? Yes?
Yes.
So 2 to the power 3 over 2, then to the power 1/3. Yes? CIS. When you combine this, you get pi plus 8, am I right? K pi divided by 4. Okay? Then this is times 1 over 3, so it should be divided by 12. Talk to me, please.
Yes.
And k is 0, 1. I'm just trying to simplify so we don't have to write too much all the time. Because each time we're going to substitute. So let's at least have a simplified form before you start bringing in the k's. Okay, and I think this is simplified enough, except that this can be simplified further to be 2 raised to the power 1 over 2. Then that would be the most simplified form. So in that case, maybe I do this. So I'm not so confusing. I write that because I still have one more step because of this guy. So k, of course, is 0, 1, 2. So the final step of my simplification will be 2 to the power half, which is just the square root of 2. Yes? I have my CIS, I have my pi plus 8k pi divided by 12, k 0, 1, and 2. So let's find all the roots now. So when k is equal to 0, the cube roots, now this cube roots is actually z. Do you agree? So, okay, so when k is equal to 0, my z, which is a solution of that equation, will be the square root of 2 CIS. When k is equal to 0, what happens to that? Pi over 12. Does everybody get that? When k is equal to 0, just have pi over 12. So we have root 2 cos pi over 12 plus I sine pi over 12. So what is cos pi over 12 is? I want calculator because I want everybody to do it like as we're saying it, not an answer that is done. So I want to hear from someone that's just checking. Yes, quickly. Then you can verify if they get it right or not. So it's what? Is it a binomial?
Yeah.
So maybe I can do that. Okay, so you get root 2 times, yes? Root 6
Plus root 2
plus root 2
over 4.
over 4 plus I, then what is the sign?
Root 6 minus root 2 over 4.
Root 6 minus root 2 over 4. Yes, this can be simplified. So if you open the bracket, now actually you can multiply by the root 2, yes?
Yeah.
Then this becomes root 12. So multiply the first one by root 2, just straight. That root 6 plus root 2, or you can start with the second one, either way is fine. You alright? You keep doing that. Use the bathroom and check it out. Maybe when you put some water on your face, whatever particle you have there. Yes, anyone?
1 plus root 3 over 2.
This is 1 plus root 3.
Over 2.
So 1 plus root 3 over 2 plus, is it safe to say 1 minus root 3 over 2?
Yeah.
What?
So plus root 3.
So this is root 3 then first.
Yeah. Second.
This is the second one is what?
Minus 1 plus root 3.
Minus 1.
Plus root 3
Oh, okay. So that will be root 3 minus 1.
over 2.
Yeah, something
Yeah.
like that. So that's the first root. Let's see the second one. When k is equal to 1. I'm leaving it in the exact form because I don't want to approximate and lose some interesting numbers. So let's leave it in the exact form. So the second part, when k is equal to 1, the solution will be the square root of 2 CIS. So when k is 1, what happens here? Speak louder, please.
Pi plus 3 over 4. So
What is that?
9 pi.
9 pi. Just say 9 pi over 12, right? So 9 pi over 12 will be, can be simplified actually. So that is simply square root of 2. 9 pi over 12 will be 3 pi over 4, yes? So cos 3 pi over 4 plus I sine 3 pi over 4. So what is cos 3 pi over 4?
Negative.
Negative root 2 over 2 plus root 2 over 2 then.
Yeah.
Root 2 over 2i. So when root 2 multiplies, this is negative 1. Check. And this should be I. Check. When k is equal to 2, which is the last, z is root 2 cis. Yes, how many pi do we have now when k is equal to 2? We have 17. 17 pi over 12. Yes? So that would be root 2 cos 17 pi over 12 plus I sine 17 pi over 12. Yes? So what is cos 17 pi over 12? Negative root 6.
Plus root 2 over 4.
Okay, so let's see. Square root of 2. Negative root 6 plus root 2 over 4. Yes? The other one? What? What is sine 17 pi over 12, please? Negative root 6. Plus root 2 again.
No, it's
Are you sure?
it's not negative root 6. It's minus all. Like,
This one? So which means there's a minus here?
Yeah, so that, yes.
It's minus everything.
Yeah,
Oh, okay. So I can put it here.
yes.
So it's minus everything, which is minus this, minus that. Yes?
Yep.
So when you multiply in, Lillian, can you verify that this is true? It is? Okay. So when root 2 multiplies, what do we get for the first one?
1 minus root 3 over 2.
Okay, 1 minus root 3 over 2 in the simplified form. Yes, the other part? 1 plus root 3 over 2i. Okay, I'm trying to look for something. Anyway, now, do me a favor. Put in your calculator. Put in your calculator the cube of that and see if you get this. Of each of them. Everything here to power 3. Everything here to power 3. Exactly the way it is. Everything here is to power 3. See whether in each case you get back 2 plus 2i. You understand that? See whether you get that, you know. If you're able to get that, then it means these are all the cube roots as required. Why do you keep getting decimals? What is that? Oh, okay, yes, that's okay, okay. Quickly, please.
How does it work?
How to do what? Leo, where's the I? There's I on the board. You didn't put I in your own.
Yeah.
I said raise everything to power 3. You missed the I.
All good. All good.
So check the second and check the
Just
third.
check.
So all good?
Yep. Shift 0. Yeah, all good.
So it means we have indeed found the cube roots. Any other question? Because I want to show you something on the graph plotter online. Any other question you try to do and you couldn't get? This is the main one. Okay. So with this, you can solve the rest if you have not completed all of them. Yes? And you can always check with your calculator each time to see the validity of your results. Okay? But of course, we're interested in how you did it. And this is how I want it to be broken down. Like, break it down in this form. So I know it's detailed, it's thorough, it's not questionable. Okay? some of the results that you did yesterday. Let's see. Have you been able to do 2A? It's not 2A in my question. Can I see the question from yesterday? Anyone? Let's open the question.
The one you put this one?
Okay. Okay, so I'm interested in 1A, result for 1A and 1C. Or maybe 1B and 1D, yeah, because I did 1A myself. Has anyone, if you have done 1A, raise your hand. 1A, I think we did it in class. 1B, okay, 1C, 1D. Alright, didn't raise your hand, you didn't try any of them.
I did try, I was doing it.
You were doing which one? 1A was done in the class, like almost everything was done. I did almost everything, right? Am I right? I showed you how to do 1A, so bringing 1A back shows you didn't do anything, sir. Anyway, so we have a lot of people done 1A, 1B, 1C. What about 1D? Raise your hand if you have attempted 1D. Okay, because I want us to observe something. So give me the result of 1B and 1D. What is the question for 1B anyways? 1B, what does it say? Z cubed
Equals minus 27.
minus 27i. And what did you get as the values of Z? First one. 3 root 3
over 2.
over 2
Minus
minus
3 over
3,
over 2I.
like that.
Yes.
So that's 1Z. So I call it maybe Z1. So there will be how many solutions? 3. So tell me what is Z2?
3I.
3i. Just that?
Yes.
So what is Z3? Negative 3 root 3.
Over 2.
Uh-huh.
Minus 3 over 2I.
Minus 3 over 2i. Like that?
Yes.
Okay. So let's talk about 1D. What is the question for 1D?
C power 4
Equals
negative 16.
negative 16.
That's it.
There's no I.
That's it.
Okay, great. So what is Z1? Root 2 plus root 2i. Like that.
Yep.
What is Z2?
Negative root 2 plus root 2.
Negative root 2 plus
root 2I.
root 2i. Brandon, can you? I don't think we can see this part. Yes. Z3?
Negative root 2 minus root 2I.
Negative root 2
Minus root
minus root 2i. Yes.
root 2 minus root 2I.
Root 2 minus root 2i. Yes? Is that what you got?
No,
Why not?
that's how I got it.
B?
I think I got it.
Okay. Can we just focus, please? We don't have enough time today. I need everyone focused. So there's something to be observed. Can you also tell me what is the question for 1B?
1B is right there. That's that.
Okay, this is 1B.
No, that.
This one.
The one
Oh, yes,
above.
I'm sorry. 1A. There is something I'm trying to bring out here. 1A is, what power is 1A?
Q.
Cube. Okay. 1A. Z cube equals what?
Negative 8.
Negative 8i. So what did we get? Z1. Quickly, please. What?
Root 3 minus I.
Root 3 minus I. Yes. Z2.
2I.
2i. Then Z3.
Negative root 3.
Negative root 3
Minus I.
minus I. Okay? That's 1A. We have 1B. Can I have 1C, please? So that's Z cube equals what? Oh, 2 power 4 equals what?
16.
16. Okay, good. So what do you get Z1?
2.
2. What do you get for Z2?
2I.
2i. What do you get for Z3?
Negative 2.
Negative 2. And Z4?
Negative 2I.
Negative 2i. Is it safe to write this as 2 plus 0i?
Yes.
And this as minus 2 plus 0i? Actually plus or minus? Yes?
Yes.
And this is 0 plus 2i?
Yep.
And this is 0 minus 2i?
Mm-hmm.
Okay, we're coming up with something. Brandon, make sure we can see this because I want to show you something today. Which other question have you done? So we have just done 2A together as a class, yes? So let's call this, please, thank you. So this is Z1, this is Z2, and this is Z3, yes? Did anybody attempt 2B? 2B.
Yeah.
Okay, so question 2B is an even power, yes?
Yes.
And the question is Z squared, am I right?
Yep.
Equals half plus root 3 over 2I. Am I right?
Yes.
So what did you get for your Z1 and Z2?
Root 3 over 2
Root 3 over 2
plus half I.
plus half I. Then Z2,
Negative root 3 over 2
negative root 3 over 2
minus half I.
minus half I. Are you sure about the first one? Please check. The three of you did it and you got the same thing. Can you square that in the calculator and tell me?
Yeah. Yeah. The first one.
What is the polar form of that number? The absolute value is what? Because we are trying to find the square root of half plus root 3 over 2I, yes?
1.
So this is square root of W. So absolute value of W is 1, yes?
Yeah.
Because half square plus this will give you 4 over 4, which is 1. And the argument, so you are going to, is a positive one, so your theta and your alpha are the same, right? So tan theta or alpha, it doesn't matter in this case. If you divide this by this, you get root 3. Yes? And that is 60 degrees, which is pi over 3. Is that what you got?
Yeah.
Okay, so if you get pi over 3, so you get CIS pi over 3 plus 2k pi divided by 2, yes?
Yeah.
And that will be pi plus 6k pi, yes? Divided by 6. Is that? So I'm particular about the first one. When k is equal to 0, I get pi over 6. Okay, so that's positive. That's correct. And when k is equal to 1, I get what? 7 pi. Yes?
Yeah.
So 7 pi. So what is cosine of 7 pi over 6? Is that negative?
Yeah.
Negative?
Root 3 over 2.
Okay, alright, okay, then you're right. I was trying to get something and I don't know why. I can't see it in this one. Now, what do you notice here? Look at these 4 results. Give me some observation.
The sign are opposite.
Say that again.
Sign are opposite.
Sign are opposite in which one and which one?
For 1D, Z1
1D.
and Z3 is opposite.
Z what?
Z1 and
Uh-huh.
Z3 is opposite.
Z1 and Z3 are opposite of each other. Okay?
As well as Z2 and Z3.
And the same thing happens here.
Yeah.
Right? They're opposite of each other. You can see the same here. You can see the same here. Yes? And where else can we see that? Okay, not in this one. This is odd, that's why we can see that.
2A, Z1 and Z2.
Is 2A even?
Z1 and
Z1 and?
Z2.
No. This is 1 minus root 3, this is 1 plus root 3.
Yeah, it's opposite.
Oh, okay. So if you multiply this by negative, no, that is not opposite.
No.
If you multiply it by negative, you get minus 1 minus root 3. That's the opposite. But if you have minus in between, only this carries the negative. That's not opposite. Do you understand? The opposite of this will have been root 3 minus 1. That's the opposite. Okay? So they are not. What else do you notice apart from opposite sign? Leo is right about the opposite sign. Yes, sir.
It's like complementary series. Conjugate.
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 So when you have an even function, even problem, even degree as a problem, the observation you will make apart from the opposite sign that some results are opposite sign of the other. And why do you think that does not matter, that they have opposite sign? Because when you square a negative sign, it doesn't really matter. So it makes sense to have opposite signs when you are dealing with even powers. Do you understand what I'm saying? Another thing we can notice is the conjugate that it's talking about. That some complex number will be conjugate of the other. But if you don't have enough, you may not be able to see. For example, here we have only 2. So maybe if we were talking about a fourth power, the remaining 2 will definitely be the conjugate of these 2. You can try it. Okay? Now, pretend this is power 4 and try to do the same. Of course, the only difference will be your k will increase. Instead of k is equal to 0 and k is equal to 1, you're going to have the same argument. Do you agree? And the same absolute value. Do you agree? So the only thing is that higher power increases the counter. K is equal to 3 and 4. Yes? And those k is equal to 3 and 4 must give you the conjugate of these 2. Does that make sense? Can somebody check this results to power 4? See if you get this back. This results to power 4. So I can be sure that my assumption is not wrong.
Doesn't work.
It's not.
Wait. Wait, no. What I'm saying is, let's see, this is it, right? Your absolute value is the same, correct? If I'm dealing with 4. The tan is still the same. I still get pi over 3, yes? The only difference when I'm dealing with the case of 4 is I have to increase the k. What?
2.
Ah, that's why. N will change as well. Okay, so maybe it doesn't. N will change and we're going to have 4 anyway. Okay, let's try it. Let's try it. If this is 4 now, okay, let's see something. Let's do that quickly. A rough idea. Z1 will be pi over 3 divided by 4. Yes? Can somebody quickly check? Pi over 12. Is that pi over 12?
Yeah.
So pi over 12. What is cosine of pi over 12?
Root 6 plus root 2 over 4.
Root 6 plus root 2 over 4. Then what is sine of pi over 4?
Root 6 minus root 2 over 4.
You don't tell me that in the head, please. Check the calculator, thank you.
6 minus root 2 over 4.
Root 6 minus root 2 over 4. Please check the calculator. Don't give us a wrong figure. Now, when k is equal to 2, this is going to be pi over 3 and 2. Yes? So let's just deal with 1 over 3 plus 2. What is 2 plus 1 over 3? That's 2 and 2, 1 over 3, which is 7 over 3. 7 over 3 divided by that is 7 over 12. So check 7 pi over 12. Cosine of that is what? Cosine of 7 pi over 12.
Minus root 6 plus root 2.
Minus root 6 plus
Root 2 over 4.
root 2 over 4. What about the sine? Speak louder, please.
Root 6 plus root 2 over 4.
6 plus root 2 over 4. Confirm that, please. Okay? So for the third one, when k is equal to 2, so we're going to have 1 over 3 plus 4. 4 number 1 over 3 is 13 over 3. Am I right?
Yes.
Divided by that is 13 over 12. So check cos 13 pi over 12 and sine 13 pi over 12.
13 over 12. So,
Negative root 6.
Negative of root 6 or negative of everything?
everything.
Thank you. So negative root 6 plus root 2 over 4. Yes, plus
Only negative
Minus.
negative here.
No,
So
just
plus.
root 6.
Just root 6 is having negative here.
Yes.
So which means if you bring out the so you have negative root 6 plus root 2 here. Is that what you're saying?
Yes.
Now if I bring out the negative, is it okay to say this is minus root 6 minus root 2 divided by 4?
Yes.
You know what this means? It means negative belongs to both of them. So which means when you multiply, you get this
Yes.
and this will get that.
Mhm.
Yes?
Yes.
So you get that. Now, Z4. Brandy, can we see this? Z4. That will become